class of organic compounds which contain hydroxyl group as their main functional group. Here is the hydroxyl group. You have oxygen atom attached and there is a hydrogen atom attached via a single bond. The oxygen is also attached to the carbon atom via a single bond. Let's see the smallest member of this alcohol homologous series. We first put the OH group, or we call it hydroxyl group or the alcohol group, and then fill the hydrogen atoms. So the first member is called methanol. Methan is for one carbon atom organic molecule. Ol is the suffix used to represent it is an alcohol. We'll see the second member of the alcohol homologous series. So let's put two carbon atoms and put the hydroxyl group and fill the hydrogen atoms. So this is the second member, which is the most widely used alcohol around the world, and this is called ethane, to show that there are two carbon atoms, and ol to show that there is an alcohol group. So an alcohol contains hydroxyl group as the main functional group. Methanol and ethanol are the first two members of this family of organic compounds. Let's have a look at the homologous series of these alcohol molecules. Here is methanol molecule with one carbon atom OH, and this is the displayed formula of that organic molecule. It shows all the bonds and all the atoms. Next column you can see it's kind of condensed formula where the bonds are not shown, yet the connection, how they connect in the structure, is clearly seen. That is also a structural, that is also one of the structural formulae. Now I can condense the whole molecule and write the atoms and their numbers. So this is going to be the molecular formula. Now let's see ethanol, the displayed formula of ethanol. And here we condense these three hydrogen atoms, and the two hydrogen atoms as CH3, CH2 and OH. We can further condense this and write C2H5OH, and here is the molecular formula C2H6O. You can see this hydrogen is also added to these hydrogens and written together. Let me show you how to do it for propanol. First we draw the three carbon atoms because it's propanol, and place the OH group at one of the two corner carbon atoms and place the hydrogen atoms. So we call this propanol in our O level, but more accurately it has to be propan-1-nol, since your hydroxyl group is on the first carbon atom. Now let's write the condensed formula. CH3, this CH3, CH2, the middle carbon and the two hydrogens, CH2OH is the corner carbon with the OH group. And further condensing this, we can write C3 H7OH. Here is the molecular formula of propanol, C3H8O. Let's see how the general formula of alcohols is derived. Here we have propanol with 3 carbon atoms and the OH group. And when we condense that and we write, we get C3H7OH. We can write the molecular formula condensing everything, so you get C3H8O. Butanol, which is also called butan-1-nol more accurately, will have 4 carbon atoms with OH, and fully condensed it's going to be C4H9OH, and further condensed you get C4H10. Let me do pentanol for you. 5 carbon atoms where H is attached, OH is attached, and here are the other hydrogen atoms. So when I condense this, I get C5H11OH. I have 5. Here it's 5 into 2 plus 1 hydrogen atoms and 1 hydrogen atoms. When I write this completely condensed, then I get C5H12O. And we can see the general formula of alcohol derived in 2 different ways. If I go through this column, we can clearly see when you have n number of carbon atoms, you will have 2n plus 2 number of hydrogen atoms, including O. And here we have n number of carbon atoms and 2n plus 1, because we are using 1 hydrogen for OH group with OH. So alcohols have 2 general formulae, which is CnH2n plus 1 OH, which emphasizes that it is an alcohol, but in more general form, CnH2n plus 2. Let's use the general formulae of alcohols to write the formula of another alcohol. Suppose you are given heptanol to write. You know heptanol means it has 7 carbon atoms. So what we can do, we substitute 7 here. Then the number of hydrogens will be 7 into 2 plus 1 OH. So you can write the simplified formula C7H15OH. We can write the formula of heptanol in the other way also. So we can write C7H 7 into 2 plus 2 O. So you get C7H16O. Both the molecular formulae are representing heptanol. Similarly, you can try octanol, even decanol.